Solar eruptions, the largest explosions in the solar system. They are the most violent drivers of Earth's space weather, yet how they are energized remains a mystery. FOXY, the Focusing Optics X-ray Solar Imager, will provide a brand new perspective on how they occur.
FOXY will observe high-energy X-rays, known as hard X-rays, that are emitted by energetic electrons that are accelerated near the onset of the solar eruptions. Unlike other wavelengths, high-energy X-rays allow us to deduce the energy distribution of the electrons, and this will help us to understand how the energy release takes place.
Solar eruptions are powered by violent releases of magnetic energy from the Sun's upper atmosphere, the corona. This poorly understood process accelerates electrons, which emit hard X-rays as they collide with ambient charged particles. Hard X-rays generated closest to the energy release site provide the most direct information on the energy release process. However, due to differences in ambient density, far fewer X-rays are produced there than in the chromosphere, lower in the solar atmosphere. This has made it difficult for previous solar instruments to observe the all-important coronal emission.
The difficulty of past solar instruments to observe coronal hard X-rays has prevented us from answering some fundamental questions about solar magnetic energy release. How does this energy release accelerate particles? How does it heat the corona? And how does it drive the different components of solar eruptions, like flares and CMEs?
FOXY will resolve these questions thanks to its innovative hard X-ray focusing optics. Unlike classical lenses, these optics focus hard X-rays by reflecting them at very shallow angles. State-of-the-art detectors will then precisely measure the position and energy of each X-ray photon. Because photons from different regions are focused onto different pixels, FOXY will observe the coronal and chromospheric hard X-ray emission at the same time. By contrast, previous solar hard X-ray instruments were routinely blinded by the bright chromospheric emission. FOXY will therefore be the first to provide a complete hard X-ray picture of solar eruptive events. Hard X-ray focusing optics have already been used in space by the NuSTAR astrophysics mission. And since 2008, the FOXY team has been developing this technology for solar observations through multiple successful sounding rocket and high-altitude balloon missions. Now, the team and technology are ready to make FOXY a reality as part of NASA's Small Explorer program.
FOXY is the ideal mission to be NASA's next Small Explorer. The team is ready and the technology is ready, and the launch date is perfectly aligned with the rise phase of the next solar cycle, where we expect to observe many solar eruptions.
By revealing the hard X-ray emission from the solar corona, FOXY will unveil the mysteries behind the most powerful eruptions in the solar system. It will unlock the key physics behind the most violent drivers of Earth's space weather, and it will bring heliophysics into a new age of discovery.